Hello everyone, today we are going to be going over the blind 75 in C++, and today we're working with construct a binary tree from preorder and inorder traversal. Now, before we get started, feel free to pause the video. I have written out our 4 questions we need to use in order to break down every single problem. We always need to figure out what the input's going to be, what data structure / algorithm / technique to use, what to do with the data, and what our output is going to be. So, to break down the problem, given two integer arrays, preorder and inorder, where preorder is a preorder traversal of a binary tree, and inorder is the inorder traversal of the same tree, construct and return the binary tree. So, we are given two arrays, preorder and inorder. We can also indicate up here for our two arrays. And it wants us to return the binary tree. So we need to return a binary tree from the two arrays. And so, in order to break down exactly a concept in trees in general, is really the concept of preorder and inorder, where the difference between the two is that let's consider a binary tree with 3 nodes, for example, where A is the root and B is the left child and C is the right child. In preorder traversal, we start from the root, and then we get the information from the left and then the right of the tree. And then inorder traversal is starting from the left, and then the root, and then the right. Those are the two concepts that we have. So, I'm just going to write this out. Order is root, left, and then right. And then in order, it's going to be left, root, right. And so, in order for us to be able to break down the problem even further, it looks like from what the problem is already specifying, is that we need to replicate the behavior of a preorder and inorder traversal from our two arrays in order to build the tree. So, from the technique that we will be using is that we will be doing a recursive approach to create helper functions to replicate the preorder and inorder behaviors. Traversals, per se. And the steps for us to be able to do this are, 1, we're going to create a helper function called build tree that takes the start and end indices of the current subtree in both preorder and inorder. We're going to have a base case that we will have if the start index is greater than the end index for our cases of preorder and inorder traversal. We're going to return null, indicating an empty subtree. And what we'll do is that we're going to create a new node with the value at the current index in preorder, and we're going to find the position of the current node's value in order. The inorder array, and then in the preorder array. And then for step 5, we're going to recursively build the left subtree by calling the build tree function with updated indices for the left subtree in both preorder and inorder. preorder and inorder arrays. And then we're going to recursively build the right subtree by calling the build tree function with updated indices for the right subtree in both the preorder and inorder arrays. Finally, then returning the current node. Okay, so now just to be able to give a breakdown on how it's going to look like. For step 1, what we'll do is that, actually it's going to be over here, given the fact we're doing recursion on this. We're going to return our function, our helper function. It's going to be build tree helper, where it's going to be preorder 0 to initialize all of our parameters, preorder dot size -1, in order 0 indicating the index, and then in order dot size -1 to get the very last element inside of our array. And now to build out the helper functions, what we will be doing this is still step 1. That's how we do it. We're going to do a private. Now we will do a tree node, build tree helper with a vector int and preorder, int pre-start, int pre-end, vector int, and in order int, in start, and then int end. In end. There we go. So I'm sure I got this right. Alright. Yep, we have a vector of preorder, pre-start, pre-end. Then we have another vector indicating for the order, in start, in end. In order and pre-order accordingly. So we have our 2 vectors that we have, and then 2 integers for each. And now we're going to do our base case for step 2, where if we have the start index of our pre-order being greater, as well as the same for the start of our in-order index, int start greater than in end, we're going to return null pointer to indicate we have an empty subtree. And then for step 3, expand this further. We're going to create a new node. It's going to be the root, preorder, pre-start for the very first index that we have. And then for step 4, we're going to find the new position of the current node's value in order. So int in order root position. It's going to be the start, since we are dealing with our in order. And then while our in order array contains the current position that we have, or root position, it's not going to equal to the root that we have for our value. And we are going to be increasing the index's current position until we actually find the value that we are looking for to be able to build out our tree. Now for step 5, we're going to recursively build the left subtree. So root all the way to left, build tree helper, where we will have our parameters accordingly. Reorder pre-start, except for we're going to have pre-start plus 1, indicating the rest of the parameter that we would have. Since we are dealing with preorder, then we will have pre-start plus the in order root position minus the start of where our in order position will be. And then we have our in order, in start, and then in order root position minus 1. We're going to build the left subtree by calling the build tree function and update indices for the left subtree in both preorder and in order arrays. Just got to keep that right there. Then we're going to do the same for the right subtree. So that means we can do the same thing, except we're going to be doing the right. And the parameters will be different. So we're going to have this part start, and then pre-end. Then we'll have in order. And not to forget, we need a +1 to indicate the position. And then we would have pre-end, in order root position. Since we're going from the right, +1, and then we'll have our in end to build it out accordingly based on the 2 arrays that we have. And then finally, for step 7, we're going to return the root. That's how we will call them. Just want to be sure I got all this right. So insert +1, then pre-end. This will be for the pre-order. Then we have the in order that we have. We have the in order array, and then we have the pre-order array. Pre-start, pre-order. That's how we do it, and then increase accordingly, and finally return the root. We're calling upon this helper function to be able to build out and call upon our tree with a root, and we take both of our given arrays that we have to build out a binary search tree. So let me just make sure this is all correct. Alright, it passes all the test cases. Let me just clean this up for you folks, and I'm going to put this in the comment section. There we go. Just double checking and submit. Alright, and to just give a breakdown on the space and time complexity for our following solution is that the time complexity for our solution is going to be O of n, constant, where n is referring to the number of nodes in the binary tree. And given the fact that we're doing a recursive call, we divide the problem into 2 smaller subproblems, and we are reducing the number of remaining nodes by half of each level. And therefore that our time complexity is going to be O of n. And then space complexity, on the other hand, is going to be O of n, where n is the number of nodes in the binary tree. And the space is used for the recursion stack during the construction of the binary tree. in the worst case scenario, the recursion stack can have a maximum depth of n, and therefore we would have a skewed tree. So yeah, this was construct a binary tree from Preorder and Inorder Traversal. Thanks again for taking time to watch this. If you found this helpful, like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.